Hi and welcome. I'm trying to learn planetary science. Today, rock and iron planets, and after we've done it, we're going to do martial arts basic training. And if you participate in the martial arts basic training, then it's with the planets of rock and iron terrestrials. The final planets to emerge from the chaos of a solar nebula were the smaller ones, of which our Earth is the largest. What you were saying, first were the gas giants, Jupiter and Saturn, and then the ice giants, Uranus and Neptune, I think they were me. And now we're having the rock and iron planets. Earth is one of them. They are known as terrestrial or telluric planets, from the Latin words for Earth, tellus, terrestris or terra. However, the other three terrestrial planets are nothing like the Earth. The term terrestrial is used merely to describe planets with solid surfaces of rocky and metallic materials. Okay, if someone's saying a planet is terrestrial, they don't mean it is like Earth, they mean it is out of solid surfaces. It is not a gas planet, it's not an ice planet, it is iron or rock, a solid substance. The growth of a terrestrial worlds, Mercury, Venus, Earth and Mars, was slow for two reasons. We said something about it took just 100,000 years to make the core of Uranus and of Jupiter and Saturn, and then a couple of 100,000 years more for the gases, but more or less just a few 100,000 years. So having that back in mind, that took a few 100,000 years, maybe a few million, let's look here. The growth of the terrestrial worlds, Mercury, Venus, Earth and Mars, was slow for two reasons. First, the rocks and metals from which these worlds formed were much less abundant than the gases and ices that formed the giant planets. Okay, it makes at least sense, so we can remember like that. There was more of it, so it was easier to build. I don't really understand now why it is easier, just because there's more of it. Whatever, that's the first reason. There was not so much rock, iron, whatever, in the solar nebula than it was of helium and hydrogen and ice. Second reason, fragments of colliding rock or metal are more likely to bounce off each other than colliding chunks of ice, because the latter have been adhesive properties. Let's read it again. Second, fragments of colliding rock or metal are more likely to bounce off each other when colliding chunks of ice, because the latter have been adhesive properties. I don't know what adhesive means, but I'm just going to say it like that. If ice and ice sticks together, it is sticking together. And the other thing, if two gases are together, helium and hydrogen, they don't repel each other. They're just together there, around in the air, or whatever. It's just around there. But if two rocks come together, they bounce off each other. That makes sense. So, over the initial emergence of rocky and metallic planetesimals close to the Sun was fairly rapid, it took much longer for them to grow into fully fledged worlds. Okay, they had quite fast rock and metallic substances were quite fast there around in the region of Mercury, Venus, Earth and Mars. And yes, I said in one of the previous videos, a little assumption. The close ones to the Sun are rock ones, we knew of Earth and Mars, and further away than the two gas giants, and then further away Uranus and Neptune, ice giants. And it makes sense, so the rocks are close to the Sun. And now we're having here also Mercury and Venus named as terrestrials, or as rocky planets. No, it makes even more sense. Or at least that supports our thesis. Okay, it was quite rapid with the wars, this rock and metallic, whatever, but it took them very much longer for them to fledge into fully fledged worlds, whatever fledged means. After perhaps 10 million years, so we haven't back in mind or 100,000 or million year for Jupiter and Saturn. Now we're having here 10 million years, by which time the giant planets were fully grown. 4 dominant protoplanets populated the inner solar system, destined to become terrestrial worlds. Okay, after 10 million years, these 4 planets, Mercury, Venus, Earth and Mars, were there as protoplanets. They were on the way to become planets. Even so, it took around 10 times longer for these worldlets to mop up the remaining planetesimal debris orbiting the Sun and grow to full size. And they needed then another 100 million years together all the other rocks in their orbit around the Sun together and become an actual planet, is what I understand, you know. To mop up the remaining. The terrestrial planets vary in scale considerably. Okay, these four ones, Mercury, Venus, Earth, and Mars, are different in their size and a lot. Earth is the largest and most massive. But Venus is almost exactly the same size. Okay, Earth is the largest of the four terrestrial planets of the 8 in the solar system. And it is the largest one and the most massive one. Venus has the same size as Earth. Mars is the second closest to the Sun. Mars is only half the diameter of the Earth. Okay, Mars is just half the diameter. Mercury is only 1/3 the size. So Mercury is 1/3 of Earth. And made almost entirely of solid iron. I'm thinking, what magnets have an effect now if someone is on Mercury? Is it always stronger? Mercury is 1/3 of Earth's size, almost entirely out of iron. Astronomers think that Mercury, the closest planet to the Sun, was originally much larger and may have lost much of its mass during a collision with a similar-sized world billions of years old. There was maybe a collision with another thing which had the size of the world. This may explain its heavy metal content. Its outer rocky shell might have been blasted away in the impact. What is that? Now, I heard about the Earth that the big core in the middle has a lot of iron in it. A burning thing out of which the volcans are fed. And so what we just said is that the middle part is out of a lot of iron, and like the Earth is the theory, and then outer around was more looser substances. And now the thing hit another thing, and like two dirty footballs smashing together, the dirt on the outside flies off and goes away, but the heavy and stable iron part in the middle stood together, whatever. What if it did not, but it was then able to form itself again? What if it was completely obliterated, that little Mercury, but the iron part was able to gather itself again together, whereas the other parts were smashed away, propelled away, and they formed another planet, like Venus or something. I have ideas, it's really good. Okay, whatever. We have read from it. Here's something else written. Mars is the second smallest of the terrestrial planets. Its surface is peppered with craters, great chasms, and gigantic volcanoes, the largest in the known solar system. So Mars has the largest volcano of the solar system. The planet's red color comes from the presence of rust or iron oxide, which blinkers the dusty Martian soil. Well, the thing is rusty. Now, that was enough for planetary science. If you were here for planetary science, you can go directly to the next part of planetary science. I will say again the word planetary science. We will do now the martial arts basic training. If you stand participate in the martial arts basic training, that is what it is. One leg up and point the foot down. And the other leg up and point the foot down. And now, side. The toes are pointing forward and stretching the inner side of the leg. And do the other side. And now go from side to side of the mantis. Now some lunges, just on front, and go back, and now the other leg in front, and back, and front, and back. And last two. And now, the knee up and back, 1 to 3 steps in the middle, the other one, the shovel snowblower. Up of the leg and back, up of the knee and back, and last two. Up and back, and again, up and back. Now stretch kicks. One hand out, kick against it. And other hand up, kick against it. You can do 3 steps in the middle. Again out, kick against it. And again out, kick against it. And again out, kick against it. Out, kick against it, and the last time. Now for frog. Again, knee up, back, but this time and in. So up, back, up, and in. And the last time with both legs. And now Klöschken kicks. So kick up and back, and up and in. Up and back, up and in. Again. And now, lunge kicks. I'm gonna kick now close to the camera. Go in front, make a lunge, and then you kick front. And again back. So now with the right leg in front, a lunge deep down with the knee, and a kick. And again back. Again in front, lunge, and kick. And now again with the right leg in front, lunge down, and kick. And the last time with the left leg, lunge in front, and kick. Now side kicks. Make a squat down, and kick to the side. Squat down, kick to the side. You're going to do a wide leg. Squat down and kick. And again down and kick. Last two. Down and kick. And down and kick. And now with wing kicks. Swing in front and to the side. And again in front and to the side. And again front to the side. Again front. And front, side, and the last, I think we started with that. So let's do one more. No, 12 push-ups. Arms underneath the elbows, and tuck the pelvis on, make a straight back, and go down. Elbows close to the rib cage. This was the first one, and the second, and the third one, and the fourth one, and now number 5, and 6, and number 7, and 8. And let's do 9 and 10, and already the last two, 11 and 12. Elbow stretching. Biker's hilltop stretch. Heel into the ground and pull the toes in. Foot to the left and pull the toes in. Foot to the right and pull the toes in. To the middle and move the leg from left to right. The other heel into the ground and pull the toes in. Foot to the right and pull the toes in. To the left and pull the toes in. To the middle and move the leg from the left to right. Legs wide apart, we finger down. And breathing out. In. And out. Breathing in, close the legs. And breathing out. That was a martial arts basic training. Thank you very much, and until next time.